The electric vehicle landscape as we know it has been entirely turned upside down. I mean, for decades now, one single technology has dictated absolutely everything. How far we can drive, how much our cars cost, even how safe we are on the road. But a massive breakthrough has just emerged from Tesla's secretive Nevada lab, and it is completely dismantling the status quo of the EV industry. We are talking about the dawn of an entirely new era of energy. Okay, let's dive into this, because the writing has actually been on the wall for a little while now. During Tesla's Q2 earnings call, Elon Musk dropped this one statement that just rippled through every corner of the tech and auto worlds. He literally just said, batteries are going to be a gigantic revolution. Now at the time, a lot of people were wondering, is this just another wave of hype? But he was foreshadowing a massive paradigm shift. Just months later, Tesla unveiled exactly what he meant. And let me tell you, it wasn't just a minor tweak. It was an earth-shattering leap forward. So this brings us to a massive million-dollar question. Is the era of lithium already over? Has the very foundation of modern tech, the lithium-ion battery that is currently powering your phone, your laptop, the car in your driveway, has it just been made entirely obsolete overnight? To understand why the whole automotive world is suddenly scrambling, we really have to look at what exactly Tesla has chosen to replace it with.
But hey, before we look forward, we kind of have to acknowledge the fall of the lithium empire. Make no mistake, lithium absolutely started the EV revolution. It's the engine that carried Tesla to dominance and shaped this whole new global industry. But beneath that dominance, lithium has these fatal flaws that have seriously bottlenecked the entire future of transportation. We're talking about hard limits that engineers have been fighting against for years, and well, we finally hit the ceiling.
So, what's the secret here? It is brilliantly simple. Raw chemistry. Well, a standard lithium-ion carries just one positive charge, an aluminum-ion carries 3. It's literally just simple math. Aluminum moves 3 times more energy per ion. Without needing any exotic materials or super complicated engineering tricks, you are instantly boosting the energy density. It is a fundamental physical advantage that lithium simply cannot match, no matter how much they try to optimize it.
Let's actually break down exactly why lithium's time is up. First off, safety. Lithium forms dendrites, these tiny little metal spikes that pierce the battery and cause thermal runaway. That's a huge fire risk. Second, degradation. A lithium battery maxes out at about 2,000 charge cycles before it's just heavily degraded. Third is supply. Lithium is scarce, geographically concentrated, and tied to these incredibly volatile supply chains. And finally, when that battery inevitably dies, it is insanely expensive for you, the consumer, to replace.
Enter the aluminum-ion breakthrough. Now, fun fact, scientists have actually known about aluminum's potential for years. I mean, it's the most abundant metal in the Earth's crust. But previously, aluminum-ion cells were highly unstable and prone to super rapid degradation. So everyone just dismissed them as totally impractical for cars, but Tesla didn't. Behind closed doors, their engineers completely solved the instability and degradation problems, transforming an impossible chemistry into a production-ready reality. And this brilliantly illustrates the sheer scale of the disruption we're talking about here. Look at these numbers. Lithium maxes out around 250 watt-hours per kilogram. Aluminum-ion, over 5,000. To put that into perspective, we're talking about a potential range jump from like 330 miles to over 3,000 miles. Charge time drops from an hour to just 10 minutes. And safety? Aluminum doesn't form those dangerous dendrites, and it remains completely stable up to 85 degrees Celsius. This isn't just an iteration, it's a total demolition of lithium. But honestly, the most jaw-dropping number of the whole shebang is this: 50,000. Let that sink in. 50,000. That is the number of charge cycles an aluminum-ion cell can endure. That translates to over 70 years of daily use. No way, right? How is that even physically possible? Well, it's because these batteries feature self-healing electrodes. The microcracks that would normally ruin a lithium battery over time, they are repaired automatically within seconds in an aluminum cell. In fact, research shows these repairs can restore 99.7% of the original structure. Sometimes it even improves performance by creating more efficient ion pathways, so the battery actually gets stronger as it heals. Plus, it has this amazing deep sleep mode. Unlike lithium, which degrades just sitting there in your garage, an aluminum-ion battery enters this crystalline-like stasis. It can sit for 10 years, lose almost zero capacity, and wake up in 30 seconds ready to perform perfectly, even in extreme temperatures from -40 to 85 degrees Celsius.
Now, I know exactly what you're thinking. This tech sounds incredible, but to get it, you probably have to shell out tens of thousands of dollars for a brand new 2026 vehicle, right? Well, this is where Tesla's strategy connects directly to your wallet. You actually don't necessarily need to buy a brand new car to get this revolutionary technology.
So the crucial point is this concept called CPMI, or Cross-Platform Module Interface. Since 2021, Tesla has been quietly, almost secretly standardizing assembly elements in its gigafactories. The cooling plates, the mounting points, the internal dimensions. They were literally designing cars for a battery that didn't even exist commercially yet. If you own a Model 3 or a Model Y built after 2021, this new aluminum-ion pack is designed to slide right into place with absolute precision. It is perfectly backward compatible with your current skateboard platform. But wait a second. Aluminum-ion cells operate at a voltage about 5 times higher than lithium. Plugging that directly into an older car should instantly fry the electronics, right? Actually, Tesla solved this with a multi-chemistry battery management system. Think of this firmware as a real-time electronic translator. Through a simple, over-the-air software update, your car's computer learns to read the new voltage, translate that new aluminum chemistry, and reprogram the inverter's behavior safely. Your old hardware effortlessly accepts this massive new power source. Just think about what this means for a second. It completely rewrites the entire relationship between driver and machine. For literally a century, the automotive industry has run on planned obsolescence. You know, building cars designed to age, so you eventually have to buy a new one. By turning cars into modular, upgradable platforms, Tesla is putting an end to that cycle for good. Hardware no longer limits progress. Software does. Let's talk dollars and cents, because this is the good kind of sticker shock. Replacing an old lithium pack used to cost anywhere up to $7,500. But because aluminum is the third most abundant element on Earth, it is just drastically cheaper to source. A new aluminum-ion upgrade pack is expected to cost between $2,000 and $4,000. You can literally triple your range and end your fire risk for less than some people pay for a fancy set of rims. As the source brilliantly puts it, instead of building cars that age, it builds cars that evolve. This dynamic shifts the entire used car market. I mean, imagine a 2022 Model 3 with a newly swapped aluminum-ion battery, heavily outperforming a brand new competitor's car right off the lot. Use Tesla's transform from depreciating liabilities into appreciating assets. Your vehicle simply grows more capable over time.
Now, what's really interesting about this slide is the massive environmental upside here. With lithium batteries, the recycling process yields super low returns because the materials heavily degrade. But aluminum-ion batteries? They retain up to 95% of their efficiency even after multiple recycling cycles. This creates an incredibly sustainable circular automotive economy. We are drastically reducing waste and emissions just by inviting owners to renew their vehicles rather than throw them away. If we zoom out for a second to the macro level, it becomes super clear that this explainer isn't just about making cars go faster or further. It is fundamentally about resetting the entire global energy infrastructure. Yes, lithium's dominance brought progress, but it came with heavy costs: geopolitical tension, environmental harm, grid vulnerability. Aluminum-ion rewrites those rules entirely, making energy storage stable, safe, and literally available everywhere. And that brings us to the vehicle-to-grid, or V2G, revolution. These new 70-year batteries turn cars from passive energy consumers into active mobile power stations. A single aluminum-ion Tesla could hold up to 2,000 kilowatt-hours. Paired with next-gen superchargers and megapacks, your car could power your entire home during a blackout for literally weeks, or even feed energy back into the neighborhood grid during peak hours to stabilize national energy demands. It's a real game changer.
Let's move to and see how this builds toward the immediate future. With the anticipated 2026 launch of the mass-market Model 2, a really harsh reality sets in for the rest of the industry. The billions of dollars that traditional automakers have just invested in lithium and cobalt infrastructure, it's suddenly obsolete. Companies that are still out there chasing marginal gains in lithium tech are building on ground that is about to collapse. The new baseline has officially been set.
This shift is no longer some distant sci-fi concept. The production lines are already adapting as we speak. The era of lithium had its time, but its limits have been reached. We are now entering an age where energy is abundant, affordable, and practically immortal. So, as this new reality reshapes absolutely everything, from your daily commute to the global power grid, I leave you with this. Are you watching from the sidelines or stepping into the future?